In this video, I'm going to show you a variation of the partial products method for multiplication, and this method uses an array model or an area model to show you how partial products multiplication works. And I'm going to purposely choose to start out with a problem that we can probably do in our head. It's 12 times 12. And what I'm going to do is I'm going to use some base 10 blocks to model a 12 by 12 array. Now my base 10 blocks, these longs are 10 long here, so I'm going to need a couple at the sides so I can make it 12 by 12 array. And I'm going to go ahead and add in a whole bunch down here because I've got 12 across and I need 12 down. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, need one more. And then I'm going to need a few unit cubes to complete my array. So now I should have a 12 by 12 array. So I know that if I were to count each individual cube here, I would have the total to my problem. What I'm going to do is I'm going to purposely pull apart this array so we can see what we call the partial products. So I've now split, I didn't change anything to my array, all I did was pull it apart slightly, kind of broke it apart. So I still have the same total number of cubes if I were to go through and count them all up. They're just not right next to each other. So what I have right here is now a 10 by 10 array, which should have 100 cubes in it. I have a 2 by 10 array, which has 20 cubes in it. A 2 by 2 array, and a 10 by 2 array. And if I were to add all of these up, these partial products, because these are all part of the product to my original problem, if I were to add up all of these partial products, I would have my original product. So I'm going to take the 100 and the 2 20s and the 4, and I'm going to find their sum. And the sum of those partial products is 144, which is the product of 12 times 12. Okay, let me show you the same thing with a problem that we probably don't know the answer to in our heads. So let me clear my board. And let's do this one as 14 times 11, one that most people don't have memorized. And I'm going to do the same thing. I'm going to make a 14 by 11 array. So there's 12, there's 13, there's 14 across this direction. Now I'm going to do 11 down. So there is 11 down. And let's go ahead and add in our unit cubes so that we have a 14 by 11 array. So this array, 14 across, 11 down, represents this problem. If I were to go through and count every one of the cubes, I would get the product of 14 by 11. So again, I'm going to split this into its partial products. And we're going to look at each of these new multiplication problems, or new arrays. So this right here is just like what we had before. We have 10 down and 10 across. We have a 10 by 10 array. Right here we have 4 across and 10 down, so we have a 4 by 10 array. Over here we have a 4 by 1 array. And here we have a 10 by 1 array. If we were to add up each of these partial products, we should get the product to 14 times 11. So I'm going to go ahead and do that. So the product of 14 times 11 is 154. Now I'm going to clear off these base 10 blocks, and I'm going to show you how we can go about doing this type of problem using partial products, but without using the base 10 blocks, because that could get quite time consuming. Alright, I'm going to purposely leave my partial product answers over here, and I'm going to go ahead and rewrite the problems that we used. This was 4 by 10, this was 10 by 1, and this was 4 by 1. And now I'm going to show you how we can do this without base 10 blocks. So what I'm going to do first is I'm going to take each of these numbers and I'm going to write them in expanded form. So in expanded form, this 1 is worth 10 and the 4 is worth 4. This one is worth 10 and the other one is worth 1. So now I'm going to go ahead and put my number 14 across the top, but instead of writing 14, I'm going to write it as 10 plus 4, and I'm purposely kind of spreading that out to give me some room. And going down the side, going down one of the sides, I'm going to put my 11, but I'm going to write it as 10 plus 1. And now I'm going to draw a box on the inside of my numbers there, pretending like this is my big array, just kind of like what I did with the base 10 blocks. So I have 14 across the top and 11 down the side. Just like what we did before, I just wrote it in expanded form, pulled apart. I'm going to go ahead and split up my box anywhere I have those addition signs so that I can see my partial products. So now each one of these little squares represents a partial product to the original problem. So this square right here represents the partial product of 4 by 10. It is a 4 by 10 array. This square right here represents the partial product 4 across by 1 down. This square is the partial product of 10 by 10. And this last square over here is a 10 by 1 array. Now, if you compare these to our partial products when you use the base 10 blocks, you'll notice that these are exactly the same thing. So without using the base 10 blocks, we can simply write our factors in expanded form, create our own box or array, and write each partial product within the array, and then find the sum of each of these partial products. So if I were to go through and do 100 plus 40 plus 10 plus 4, just like I did over here, I would get the answer to my original problem, 14 times 11. All right, let me show you one more without using base 10 blocks at all, and we'll do a larger problem. Let's do 34 times, let's do 28. So if I were to use the box method to do partial products, or the area method, I would write each of these in expanded form, pulling them apart. This would be 30 plus 4, and this would be 20 plus 8. So I'm going to write 34 across the top, but I'm not going to write 34. I'm going to write 30 plus 4. And going down the sides, I'm going to write 28, but I'm going to write 20 plus 8. I'm going to fill in a box to make it look like an array, just like what we did with our base 10 blocks. And I'm going to split it up where I see the addition signs so that I can see my partial products. So now in this box right here, I have a 4 by 20 array, which is 80. In this box, I have a 4 by 8 array, which is 32. Over here I have a 30 by 20, which is 600. And down here I have a 30 by 8, which is 240. So these are what is known as the partial products to my original problem. So if I take each of those partial products, 600, 240, 80, and 32, and I add them all up, I should get the total product of my original problem. So here I have 2, here I have 12 and 3 is 15, carry my 1, that gives me 952. So using the area method for multiplication, I was able to find partial products to help me find the total product of 34 times 28.